I want you to think of your mitochondria as a powerhouse. And in the powerhouse, we must have oxygen. So if you went to a traditional coal-burning power plant, it has to have oxygen to keep the fire going. So that keeps the smoke and basically stokes the fire. And actually, a fire itself cannot continue without oxygen. So think of your mitochondria as this very powerful power plant using a ton of oxygen. Well, when you have this production of ATP that's slowing inside the cell, what happens is your body shifts from utilizing the powerhouse as efficiently to an area outside the cell called the cytosol. That's this kind of gooey part outside the cell. It's a fluid-filled region. And think of that as it moves to a campfire out front. So I can produce some energy and some heat at a campfire, but it is going to be nowhere close to my powerhouse. So the technical term for that is glycolysis. It's the metabolic pathway that converts glucose into energy in the process of production of ATP, and glycolysis happens in that campfire. And it involves the breakdown of glucose into two molecules. It makes it into a thing called pyruvate, which could then be used inside the powerhouse to produce ATP, and it also produces NADH. And NADH is used to produce more ATP through the process of what they call oxidative phosphorylation. So think of that as glucose burning with oxygen, which occurs inside the mitochondria. So glycolysis can occur without the presence of oxygen. So the campfire can burn without the presence of oxygen. And when oxygen is present, the pyruvate that is produced during glycolysis is further broken down in the mitochondria through a process called aerobic respiration, which actually generates your ATP. So what that means is that's when your cell is burning with oxygen, and you can actually use that byproduct as fuel. So that's why when you're looking at exercise, certain exercise you can do for a longer period of time and some you can't. So when you are doing sprints, let's say, what's happened is as you speed up and your heart rate increases, your oxygen levels are going to go down, and your body actually flips to a more glycolysis pathway, and that's why you can't sprint for an hour. Your oxygen levels start to drop, your production of ATP goes down, and then you get also a production of lactic acid, which is a byproduct of glycolysis, which is setting the threshold of how fast and how far you can go at that rate.